Hey, my name's Tyler Vegan, and I'm here to talk about spurious correlations. You might have seen some of my charts based on a program I wrote to find correlations between completely unrelated sets of data. For example, there's a correlation between the divorce rate in Maine and the per capita consumption of margarine in the United States. And there's a correlation between the number of worldwide non-commercial space launches and the number of sociology doctorates awarded in the United States. But what do those mean? Anyone can plainly tell that there's not actually a connection between margarine and marriage. But everyone considered the hypothesis for a split second and said to themselves, are we launching sociologists into space? And that's the part that's so cool. We were scientists, if only for a moment. We saw data, we formed a hypothesis about that data in the form of a causal mechanism, and then we rejected that hypothesis based on our personal experience with the world. That's a big deal, and it's the part that computers can't do. Research is about discovery, but only humans can actually make discoveries, though computers are a great tool. The purpose of the spurious correlations I show is not to say that data is ambiguous and you can interpret it however you want. No! Statistical data can show correlations, and then it's up to us as rational thinkers to establish whether there's actually a connection between the variables or if it's merely a coincidence. We do this in two ways. First, we need to mathematically prove that a correlation really exists. Second, to establish a connection between two variables, we need to establish the why. The why is usually called the causal mechanism. The causal mechanism is like the verb in a sentence connecting two things together. For example, there's a correlation between how many videos I've watched by SciShow Space and how much I know about space. The causal mechanism is that Hank and Caitlin are teaching me more about space. The teaching is the verb, and it's causing me to know more about space. Finding causal mechanisms is the key goal of a lot of scientific research, because when we find causal mechanisms, we learn that much more about the world around us. Sometimes we see a correlation that we can't explain, and it might inspire us to search for a potential cause. A good example of correlations leading to conclusions is the connection between smoking and lung cancer. In the early 1900s, the incidence of lung cancer was on the rise, and no one really knew why. Then, in 1929, German physician Fritz Lickent published a paper in which he showed that lung cancer patients were particularly likely to have been smokers. That is, there's a correlation between smoking cigarettes and the incidence of lung cancer. That paper led to a lot of research in which we learned about the dangers of smoking, but it never would have happened if someone hadn't seen the correlation and then researched. To sum up, correlations are a great starting place, but it's up to us to be critical of the correlations that we see. Correlations between two variables could be merely coincidence, or they could be the result of an underlying causal link. And every time we see a correlation, we have the marvelous opportunity to try to figure out which one it is. I'm Tyler Vegan. Have a great day.